Hi students, welcome back. Today we are going to solve the majority element problem on LeetCode. Let's look at the problem statement first. The problem statement says we are given an array of size n, okay, and we have to return the majority element in the array. So how is a majority element defined? A majority element is the element that appears more than n by 2 times in an array. So in the array, any element which occurs more than n by 2 times is called the majority element. In the given array, we have to return such an element. And we can assume that such an element always exists in the array. So there are few constraints that are given, nothing significant. It's just that the numbers are in the range of an integer only. Okay, let's look at few examples. The first example says we are given an array of size 3. So n equal to 3 in this case. So n by 2 would be 1. So we have to find an element which occurs greater than 1 times in the array. So there are two elements in the array. 3 is occurring 2 times and 2 is occurring 1 times. So clearly 3 is the answer in this case because only that is occurring more than one time. Okay, let's look at another example. In this example, the size of n is 7. Okay, so n by 2 is 3. We are given two elements in this array. So the frequency of these elements is 2 occurs 4 times and 1 occurs 3 times. Clearly, 4 is greater than 3, hence our answer is 2. Okay, so only 2 occurs greater than n by 2 times, hence 2 is the answer. So let's look at the solution by working through an example. Let's see, we are given an array of this size. Okay, here n equal to 9. So if you closely observe, based on the assumptions, so n by 2 which is 4 here, so we are given that there is an element which occurs greater than 4 times. That means there is an element x which occurs at least 5 times in this array. At least greater than 4 times, which is why at least 5 times in this array. So now if array is of size 9, right? So if an element occurs at least 5 times, n by 2th place, which is the midpoint of the array, would always be that majority element because it occupies 5 places, right? So wherever you start, n by 2th element would be always the majority element. So let's sort this array and see. So in this array we have two twos. So if we sort this array, 3 threes and 5 fours. Okay. So n by 2th element is here, which is 4, which is the majority element. So this will be true if the majority element is at the start of the array, end of the array, or middle of the array, anywhere, because of the 9 places, 5 places are occupied by the majority element. So to occupy 5 places, once you sort, it should definitely be at n by 2. So that is the logic for this. So algorithm is sort and return n by 2th element. That's all. Okay, so this is one approach. The other approach is to find the frequency of the characters of the numbers in this array. So for example, if we calculate a frequency map for this given array, it would be 3, which is occurring 2 times, 2, which is occurring 2 times, 4, which is occurring 5 times. Now what we will do is, we will go through the map element by element, and whenever we find an element which is greater than n by 2, which is 4 in this case. So whenever we find an element which has value greater than 4, we will return the key of that. So when initially we are at here, is 2 greater than 4? No. So we will continue, we will check the next one. Is 2 greater than 4? No. We are here, is 5 greater than 4? Yes. So we will return 4. So this is the approach by constructing a map. So here basically we are constructing a frequency map of the array and returning the element which has the frequency greater than n by 2. Okay. These two are intuitive approaches, but the third approach which we are going to see is called the Moore's voting algorithm. This one is not intuitive. You will have to know the algorithm in advance to use this. So let's discuss the algorithm first. So the algorithm is called Moore's voting algorithm. So the algorithm says take two variables, candidate and counter. Okay. Initially, both of them are 0. Okay. What we will do is, while traversing the array, when the counter is 0, we will assume that the element at the current position is the candidate. For example, initially we will be here at this point, counter is 0. So, we will assume that the candidate is 3. And when when the current element is equal to the candidate, we increment the counter. Okay, now we move to the next pointer. Current element is equal to the candidate, so we again increment the counter. Now when we reach 4, at this point current element is not equal to the candidate. So when current element is not equal to the candidate, we decrement the counter. Okay. Now when we reach here, again it is not equal to the candidate, we decrement the counter. So at this point we have reached 0. That means the majority element 3 has been cancelled out. So this part of the array, we didn't find any major element, it just cancelled out. So now again we will start here. Here again counter is 0, so we will assume that 4 can be a candidate and we will increment the counter to 1. At the next step, it is same as the candidate, so we will increment the counter to 2. At the next step, it is not same as the candidate, so we decrement. For the next two places, they are same as the candidate. So we just increment the counter on each occurrence. So finally, the candidate that we are left with is 4, which will be our answer. So the counter value may not be showing the size or the major frequency of the candidate, but whatever is remaining in the candidate is the answer. So basically it is cancelling out all the other occurrences and only the majority element will remain. So let's look at another example using this algorithm. So here again let's take candidate and counter. Okay, initially both are 0. Okay, now when we are at this point, so we can assume that our candidate is 7 and counter would be 1. So now when we move to the next point, at this point candidate is not same as the current position, so we decrement the counter. So we reach 0. That means these two cancelled out. Next again, counter is 0, so we will take a new candidate which is again 7 in this case, and we will change the counter to 1. Again 6, so this will become 0. Again these two cancelled out. At this point, we will choose a new candidate because counter is 0. Okay, and we'll change the counter to 1. Then again counter will become 0 because the next element is 2. Again these two cancelled out. Okay, so at this point again counter is 0. So we pick a new candidate and change the counter to 1. Then next one is again same as this one. So the counter becomes 2. Next two are not same as the candidate, so the counter will decrement twice. So again these 4 cancelled out. Now our new candidate is 2 and counter is 1. 7 is not same as 2, so again we will decrement. So again these two cancelled out. Next again similarly 6 and 7 will cancel out and 7 will remain. Okay, so basically we are cancelling out the majority element's votes and the remaining element would be our candidate. Okay, let's look at the implementation for all the three approaches. So first let's do the array implementation. So the first step is sorting the array. Arrays.sort nums, and we have to just return nums of nums.length by 2. So that is because since it occurs more than n by 2 times, it is guaranteed that it will be at the midpoint of the array. Okay, now let's submit this and see. Yeah, it got accepted. For the array sort approach, what is the time complexity? Sorting is the major step here. There is nothing else. Sorting in the best case we can do in n log n. So it's order of n log n. We are not using any extra space here. So it is order of 1. Or it will depend on the sorting algorithm. Okay. Now let's look at the second approach. The second approach we will need a map. So a map which takes integers and keeps a count which is again integer. Okay, so the hash map is initialized. Now we have to populate the map. So we populate the map by traversing the array. So for each num, what do? We have to set the number in this array. You have to set the number with default value 1, and if the number already exists, we will do a sum. So the merge operation, what it does is, if the number doesn't exist in this map, it will initialize it with 1. If the number exists, to the existing value, it will do this function. It will apply this function, which means it will increment by 1 basically. So at the end of this operation, we will have the map fully set. So now we have to traverse the map, which is we should get the map entry set, get a stream. Okay, and on the stream we have to filter. We have to filter an entry which has value greater than majority. What is majority? Majority is nothing but it is nums dot length by 2. Okay. Once we get such an entry, we have to get the key out of it. Map dot entry dot get key. Okay. So once we get the key, we can just return. We don't have to traverse further, which is why we'll do a find first. We will always get an element, but for just completion, we have to return -1 if no such thing exists. So what we are doing here, we are getting a stream out of the maps entry set. We are filtering an entry which has value greater than majority. Majority is nothing but n by 2. And from that value, we are getting the key and we are returning that key. Okay, that's all. So let's run this and see. Yeah. So what is the time complexity of this? We are traversing the array once to form the map. Next, we are traversing the map and finding the entry which has value greater than the majority. So, which would be order of n. Similarly, we are creating a hash map for the numbers. So, the space complexity would be order of n as well. Okay, so let's look at the third implementation now, which is the Moor's voting algorithm. In this algorithm, we need two variables, candidate and counter. So, once we have this, we have to traverse the map, and if counter equal to 0, we have to set the candidate to be number. Okay, and if current number is equal to candidate, we have to increment the counter, else we have to decrement the counter. At the end of it, we just have to return the candidate. So we took two variables, candidate and counter. When the counter is 0, candidate would be equal to the current number, and if the number is equal to candidate, we increment the counter. If it is not equal, we decrement the counter. At the end of the processing, whatever is left in the candidate would be our result. So we just return the candidate. Yeah. So what is the time complexity of this approach? We are just traversing the array once. So it is just order of n. Okay, and we are not using any extra memory other than these two variables. So the space complexity is also order of 1. So of the three algorithms, array sort, it takes more time, order of n log n. HashMap takes order of n, but it needs extra memory. Whereas the Moore's voting algorithm, it it takes order of n time and no space at all. So the Moore's voting algorithm is the best one to use in this scenario. Okay. As always, keep practicing and improving your problem solving skills. If you have any questions, do leave a comment. Please like, share and subscribe. Thank you.